One person.
Sorry, good afternoon.
Good afternoon.
Good afternoon. So, last class we discussed about that quadrature amplitude shift gain. So, what way this one is different from previous phase shift gain? What is the advantage of QASK compared to PSK? Phase shift gain. Quadrature amplitude shift gain. The actual name is quadrature amplitude phase shift gain. The phase angles are similar to that QPSK, but here the amplitude variations also takes place. Another important variation is the variation in phase angle from symbol to symbol, as well as amplitude variation also takes place. In PSK, the phase angles are different, amplitudes are same. That is less immunity to noise. But in this QASK, phase angles and amplitudes are different. Therefore, immunity to noise is more. That is the advantage of PSK compared to PSK. You have to note down that important point. Okay. Now today we will discuss about that transmitter block diagram and receiver block diagram of generalized block diagrams of quadrature amplitude phase shift gain. Shall we start the lesson? Come on. Okay. Shall I Sharing my screen to you.
Yes, ma'am.
Okay. Before going to discuss about the transmitted block diagram of this QASK, yesterday previous class, again here you can refer, because last year old question paper, that total question is given for QASK, quadrature amplitude phase theory. Here you will design your own. So here we taken in this example in your textbook 16 QASK. Please mute your phones. Please mute your. Okay. Please listen. So here in this case, this is the constellation diagram for 16 QASK. 16 means the number of symbols are 4. 2 to the power of 4 is the 16. The constellation diagram for this one is 1. This is one symbol. This is another symbol. 1, 2. Each quadrant, the 4 symbols are there. 1, 2, 3, 4, like that. This is the constellation diagram for 16 QASK system. So here the distance, let us assume the distance between the two symbols is equal to 2a. Let us consider here. The distance between two symbols is equal to 2a. So here we can allot that amplitudes for this one. A comma a, 3a comma a comma 3a, 3a comma 3a, like that. So from that one here, we derived the expression for a for assuming that distance, that is an ES is an average normalized energy of the signal. ES is equal to, like that here. They are calculated like this every time. Similar way here also, let us given one question in your examination. Design 64 QASK. How we will do? Listen to me. Here we can design 64 QASK. 64 QASK. 64 QASK. N is equal to 6. The number of bits per symbol is equal to 6. 2 to the power of 6 is equal to 64. So each quadrant, the 16 symbols are present. And let us assume the distance dA is equal to 2a. So how we can allot that amplitudes for that each symbol? And from that one here we can find out that ES. From that one here we can derive the A. Same procedure here. Like that here we can design that 64 QASK, and here we can find out the ES like that. So example I will explain here before going to discuss about this transmitter. The 64 QASK, that is the procedure for anyone. That is a generalized procedure here. So here in this one, in 64 QASK, 1, 2, 3, 4. This is a U1 of t orthonormal coordinates. This is a U2 of t. 1, 2, 3, 4. Again 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That means in first quadrant, 16 symbols are there. Each symbol is consists of 6 bits. Here let us assume 0, 0, 0, 0, 0, 0. This is the one symbol. Next one is 0, 0, 0, 0, 1, like that. 4. So here we can indicate that 16 symbols. Similar way, wait chestnara.
Wait chestnara.
Hello. Okay. So here the 16 symbols are there here. We can give, let us assume A comma A is the amplitude for this one. Let us assume the distance between these two adjacent symbols is equal to, let us assume we are designing 2A. So here this is an A comma A. Let us assume this is an 3A comma A. This is an 5A comma A. This is a 7A comma A, like this. So here you can find out anyone. The distance between adjacent symbols are 2A. And then here you can find out from ES is equal to ES is equal to ES. Calculate చేస్తారు. This is a 0, 0. This is ES, resultant one. Again, this is an ES. This is an ES. This is an ES. Like that. Yesterday's class, our previous class, we are calculated ES. We are derived that one. ES is equal to, first one is an A plus A square plus A square to A square. Like that. How many are there? This is ES is equal to, how many in this quadrant? 16 are there. So here something into, can calculate how much you get into A square by 16. Then here can find out A. So that is, we are designed D is equal to distance between, that is equal to 2A. We can substitute in this one, we will get actual distance here. And A is equal to value that is related to 64 QASK. 64 QASK. Like that here you can find out A value.
Ma'am,
Hello.
ma'am, allow చేయమంటున్నారు.
Hello.
నన్ను
Amma? Okay. So this is the procedure to design any QASK, 8 QASK, 16 QASK, 64 QASK, 32 QASK, like this. Okay. So that is the procedure you have to follow. Once you can understand that procedure, easily we can design any type of QASK system. And that's why here you can take an, that is an 16 QASK system is an example for that one. And then here go for the values of this one. Again, here we can repeat this one. Yesterday, previous class we designed. So here we can indicate AE of t is equal to K1 root of 0.2 and A0 of t is equal to K2 root of 0.2. Already we are derived this one. So AE of t is equal to A0 of t is equal to plus or minus. Here the values here we allotted this one from this one. What are the amplitudes of this one here? Here A comma A, 3A comma A. So here this is a 1A. Here that is amplitude 3A. Like this here we can allot this one plus or minus 1 root of 0.2 or plus or minus 3 root of 0.2. So 1A or 3A. Here we can represent it that one. Okay. So these are the values you can allot this one. So AE of t, A0 of t. Like that here derive that one. Then you will get the values for everyone. AE of t, A0 of t. This is the procedure to find out this one. So here AE of t and A0 of t. Again here you can check that AE of t and A0 of t. In this case here we can AE square average. Here we can find out AE square bar equal to A0 square bar. equal to 1. We can find out that also. That means plus or minus 0.2 plus or minus 3 into 0.2. 4 values for each one. So 0.2 root of whole square plus again minus 0.2 root of whole square minus minus plus అయిపోతుంది కదా plus 3 into root of 0.2 whole square plus 3 into root of 0.2 whole square divided by 4. Average kada. ఎంత వస్తుంది? Here you can find out 0.4, sorry, 0.2 plus 0.2 plus 9, 1.8 plus 1.8 divided by 4. Divided by 4. This is equal to 4 by 4 equal to 1. So here we can observe that amplitudes. Here we can select these values. So A square of bar and A naught square bar, average values of this one equal to 1. Here we can maintain. This is an off and this is an off amplitudes divided into equally. So here we can consider all those things. Then we can design. So 64 QASK, 8 QASK, like that. So are you understand the procedure to design the 16 QASK and 64 QASK from the constellation diagrams? These are not given anywhere. Only 16 QASK is given in your textbooks and any other textbooks. I also observed or collected the information from the net also. Anywhere only 16 QASK is given, but 64 QASK where design your own according to that procedure. Are you understand? Emma, my voice is audible to you?
Yes, ma'am.
Procedure తెలిసిందా మీకు ఎగ్జామ్ లో ఎలాంటిది ఇచ్చిన డిజైన్ చేయమని ఇచ్చిన దట్ ఈస్ ద ప్రొసీజర్. D is equal to 2A ఉండేది యాంప్లిట్యూడ్ సెలెక్ట్ చేసుకుని మీరు డిజైన్ చేసుకుంటా రావాలి. ఓకేనా?
అలా చేయమని చెప్తున్నారు మ్యామ్.
అలాగే. మీకు ఎందుకు నేను ఈ పాయింట్ నేను చెప్తున్నాను అంటే యాక్చువల్ గా QASK is not given in your syllabus, but that is one of the part in PASK, quadrature phase shift keying, quadrature amplitude phase shift keying. So in our last year question paper, here 4 sets are there. In the one set here, the total 2 questions are related to QASK. You have to design a particular QASK system. What is the bandwidth? What is like that? So many questions are from that QASK system. That's why here we can concentrate on that one. Okay. Okay. Then now we discuss about that QASK transmitter. So this is an 16 QASK transmitter. So here in 16 QASK transmitter, so each symbol consists of 4 bits. That's why I taken 4 bits: BK, BK plus 1, BK plus 2, BK plus 3. So BK plus 1. So here that is a combination. Here we can indicate that 0. First for 4 bits: 0, 1, 2, 3. Otherwise 1, 2, 3, 4 bits. The combination here. So first 2 bits B1 and B2 are given to D-type flip-flop. So the D-type flip-flop here, that is entirely depending upon clock. Clock is also compulsory for this one. Here another block, here we can add this one, clock. The clock that can be produced as the duration is equal to TB duration. Clock period equal to clock period equal to, here you can indicate clock period equal to symbol duration. Symbol duration. That is TS. So this is applied to clock here. This is as the input to this all D-type flip-flops. So clock. Then here BK and BK plus 1. First two bits are given to first D-type flip-flops. Then when this is activated, then that can be given to this one. And again here we can given to digital to analog converter. 2 bits at a time here. Digital to analog converter. Analog to digital converter. The output of this analog to digital converter is AE of T. According to this example 16 QASK, AE of T. So plus or minus 0.2 root of 0.2 or plus or minus 3 root of 0.2, either one. Here we can indicate that this is a root of 0.2 plus here minus root of 0.2, like that. Here we can anyone. So either 4 values. The output of this digital to analog converter is converted into, so this is the AE of T. So root of PS cos omega naught T. Similar way here also, third bit and fourth bit are given to the D-type flip-flop according to the duration, and that can be again given to digital to analog converter. So gives the corresponding the A naught of T. Again A naught of T. It has 4 values. Plus or minus root of 0.2 plus or minus 3 into root of 0.2 values here. Like that here. This is multiplied with root of PS sin omega naught T. Then what is the next block? This is given to, what is the output of these balanced modulators or multipliers? Generally balanced modulators are used instead of using multipliers. What is this one? AE of T root of PS cos omega naught T. Cos omega naught T. Similar way, A naught of T root of PS sin omega naught T. Sin omega naught T. So here that is an adder. We can add these two. Adder. You will get QASK signal. QASK signal. This is for 16 QASK signal. Now we can design the transmitter for 64 QASK signal. QASK. 64 QASK. 64 QASK and how many bits are there? N is equal to
6 ma'am.
6. అప్పుడు మనము AE of T కి ఎన్ని బిట్స్ ఇస్తాము యాజ్ ఇన్పుట్స్ గా డిజైన్ చేసుకోవాలంటే BK plus 1 BK plus 2 అన్ని కలిపి సో ఫస్ట్ అన్లాక్ టు డిజిటల్
మేడం ఎలో అంటే చేయరా మేడం కొంతమంది ఉన్నారంట
అన్నారు ఎలా వచ్చేస్తుంది రిమైనింగ్ 3 వచ్చి సెకండ్ డిజిటల్ టు అన్లాక్ కన్వర్టర్ కి ఇస్తారన్నమాట అలా మనము డిజైన్ చేసుకోవాలి ఏమో So like that here we can design that one 64 QASK like this. Are you understand that operation of this transmitter block diagram? Please note down. This is very important. 4 bits are there. N is equal to 4. Here equally we can separate 2 bits. 2 bits per first AE of T form and the next 2 bits are A naught of T. Or form. These are orthonormal. Root of PS cos omega naught T multiply. Again, A naught of T is multiplied with root of PS sin omega naught T multiply. So these are the orthonormal coordinates. This is when here we can observe that the equation also resembles to PASK, phase shift keying, quadrature phase shift keying. Okay. That angles also can allot that one according to that QAS. Quadrature amplitude shift keying annaru kabatti. So here the phase angles are also here we can maintain same phase angles. Okay. 90 degrees for each symbol here we can maintain that distances. So here that is in according to that. Then here after generating this one here, we can retrieve the original signals. Before going to discuss about the receiver block diagram, what is the bandwidth of this signal? Already we are familiar with that power spectral density of QPSK and M-array PSK. QPSK ki chesam kada? ఎలా చేశారు QPSK కి QPSK ఈక్వేషన్ కూడా సిమిలర్ టు దిస్ వన్ ఆల్సో ఎలా ఉంది QPSK కి ఈక్వేషన్ BE of T root of PS cos omega naught T plus B naught of T root of PS sin omega naught T. So same are similar to this equation also. What is the bandwidth of that one? చెప్పాలి మీరు అనలైజ్ చేయాలి సో QPSK కి పవర్ స్పెక్ట్రల్ డెన్సిటీ ఎలా డిరైవ్ చేయాలో మీకు తెలుసు బ్యాండ్విడ్త్ ఎలా వచ్చింది మీకు బ్యాండ్విడ్త్ ఫర్ QPSK FB by 2 plus FB by 2 that is nothing but FB ఎలా ఫైండ్ మీకు ఏమేం కాంపోనెంట్స్ వచ్చినాయి F0 plus F equal to here we can indicate that this is an TS equal to 1 already calculated. Ikkada in this QPSK TS is equal to 2 TB. Therefore here we can substitute 2 TB equal to 1 here F0 plus F. Then so F0 plus F equal to 1 by 2 TB. Am I correct? This is equal to FB by 2. Manaki enta vachindi FB by 2 here we can observe that this one. This is an FB by 2. Okay? FB by 2 this point. At this one also another FB by 2. Total bandwidth is equal to 2 into FB by 2. So that is equal to the bandwidth is equal to for QPSK, that is FB. For this QASK, what is the bandwidth? Ikkada TS is equal to symbol rate or symbol duration. So that is in QPSK, the symbol 2 TB. In QASK, according to this one, this is a 16 QASK. TS is equal to enta?
4 TB, ma'am.
Very good. TS is equal to 4 TB. 4 TB. What is the generalized formula for calculating bandwidth? The bandwidth is equal to, already you derived that one. Bandwidth is equal to 2 into, chapal naku. 2 into, according to this one. ఇక్కడ FB by 2 వచ్చింది మనకి, కానీ ఇక్కడ ఎంత వస్తుంది?
FB by 4,
FB by
4.
4. The bandwidth is equal to FB by 2. Okay, so here we can generalize one. So MQASK, N is equal to number of bits, N indicates. So the bandwidth is equal to, here we can generalize one. ఎందుకంటే 16 QASK అవ్వచ్చు, 32 QASK అవ్వచ్చు, 64 QASK అవ్వచ్చు. Like that, here number of bits that can be increased, that is the number of levels also increased. Therefore, the generalized bandwidth for this one equal to, ఎలా రాస్తారు? 2 into FB by N. Okay, so what is the bandwidth of MRA PSK? MRA PSK bandwidth anta?
2 FB by N, ma'am.
2 FB by N. మరి M array or M array QASK, what is the bandwidth, generalized one? 2 FB by N. 2 FB by N. So here we can indicate that for 16 PSK, 16 array PSK, 16 QASK, here we can, these are the very, very important questions to you. 16 PSK and 16 QASK. Bandwidth enta? 2 into FB by N is equal to enta? 4. Similar way, here also 2 into FB by 4. That means the bandwidth of 16 PSK or MRA PSK and bandwidth of MRA QASK are same. The bandwidths are same, but distance D equal to, what is the formula for MRA PSK? MRA PSK. What is the bandwidth? Bandwidth for MRA PSK, generalized one.
2 FB by N.
Please. 2 into root of N into EB sine square 5 by 2 to the power of N. This is the formula for D. Distance for QASK. That is the issue. Here we can indicate 16 దానికి చేస్తారు కదా, ఎంత వచ్చింది? 2 into root of ఎంతమ్మా? 0.4 EB. This is for 16 QASK. Now here we can substitute this one. For 16 array PSK. Array PSK. What is the distance? Distance calculation. Amma.
Hello, చేయమంటున్నారు మేడం.
Okay. This is equal to into here n is equal to 4 into EB sine square 5 by 2 to the power of n. Here you can calculate. So which one is an advantage? Bandwidth is same, but distance between these two are different. Okay, you can calculate this one and tell me. So what is the value? So which one has the distance is maximum for 16 QASK or 16 array PSK? చెప్పాలి నాకు A9 క్యాలిక్యులేట్ చేసి చెప్పండి అమ్మా.
Okay, ma'am.
Calculate చేసి చెప్పండి. Which one is an better? Which one has the distance is maximum? That one is an advantageous compared to that other one because the bandwidths are same. But 16 array PSK ki distance anta in terms of EB. For 16 QASK ki distance anta in terms of EB. Which one is an maximum value? So the distance is maximum, that indicates that the errors are minimum. ఎందుకంటే ఒక సింబల్ కి డిస్టెన్స్ ఎక్కువగా ఉంటే ఓవర్లాపింగ్ అనేది ఉండదు. డిస్టెన్స్ అదంటే నాయిస్ అడిషన్ ఆర్ ఎర్రర్స్ occurred or reduced. That's why here you can prefer the which one has a large distance when compared with other one. So that is the best system. For both the systems, which one is a better one? Please, anybody? N plus 4 substitute చేసిమే కదా. So for 16 array PSK, the value is నేను చెప్తున్నాను ఎంత 2 into root of 0.15 EB. ఈ వాల్యూ వచ్చిందా మీకు? Whereas in 16 QASK, the value is 2 into root of 0.4 EB. ఈ రెండిట్లో which one is a greater value? Which one has a greater value? Emma. 2 into root of 0.4 EB greater. 2 into root of 0.15 EB greater value. Say loud. Which one is the greater one? చెప్పండమ్మా. So here you can observe that the distance of that 16 QASK is greater than this 16 PSK. Therefore, here the bit error rate is less in 16 QASK when compared with 16 array PSK. Okay? Okay, na? The bandwidths are same, but 16 QASK distance is greater than that 16 MRA PSK. That's why the error rate is less in 16 QASK when compared with 16 array PSK. Please note down that is the one of the important point. ఓన్లీ మనము చెప్పేసుకుని వెళ్ళిపోయి బ్లాక్ డయాగ్రామ్ నేర్చుకోవడం కాదు, కంపారిజన్స్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్. వై దట్ వన్ ఈజ్ అన్ అడ్వాంటేజెస్ టు అదర్ వన్, ద కంపారిజన్స్, బ్యాండ్విడ్త్ కంపారిజన్స్, డిస్టెన్స్ కంపారిజన్స్, అలాగనమాట. అవి మీకు ఎక్కువగా ఇస్తూ ఉంటారు. ఈవెన్ దెన్ గేట్ ఆల్సో, ఈవెన్ దెన్ ఇన్ కాంపిటేటివ్ ఎగ్జామ్స్ ఆల్సో దీస్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్. ట్రాన్స్మిటరు, రిసీవరు ఇవన్నీ జనరలైజ్డ్ థియరీ మీరు రాసేయచ్చు. That is common for all those one modulation techniques. But comparisons, these are the very very important. Distance ఎలా ఉంటుంది, bandwidth ఎలా ఉంటుంది, ఎలా అనలైజ్ చేయాలి, ఎలా డిజైన్ చేయాలి. సో ప్రాక్టికల్లీ దీస్ ఆర్ ఇప్పుడు 16 QASK రిసీవర్ ట్రాన్స్మిటర్ బ్లాక్ డయాగ్రామ్స్ ఉన్నాయి. 64 QASK వచ్చేటప్పటికి మనం ఎలా డిజైన్ చేసుకోవాలి. సో దట్ ఈస్ వన్ ఆఫ్ ద ప్రాజెక్ట్. లైక్ దట్ మీకు ఎక్కువగా QASK అండ్ శాటిలైట్ ఈ ఫ్రీక్వెన్సీలో ఉంటుంది. డౌన్ ఫ్రీక్వెన్సీ, డౌన్ లింక్ ఫ్రీక్వెన్సీ, అప్ లింక్ ఫ్రీక్వెన్సీ. QASK 64 QASK ఈజ్ యూజ్డ్, modulation technique is used. అంటే ఏంటి? As a engineer here, communication engineer, so you have to know all those things. In DRDOs and in airports, as a communication engineer మీరు అపాయింట్ అయ్యారు అనుకోండి, సో ఇవన్నీ మీకు తెలియాలి. కంపారిజన్స్ in even then in DRDO, BPSK used for radar systems because of less complexity in circuit diagram when compared with all those modulation techniques, and distance between two symbols is maximum. The bandwidth also FB. So that means here we can compare the each modulation technique with the other one. Then here we go for which one is best for our requirement, according to our application. So that is the importance of these communications. So these are the advanced communication modulation techniques that are used in all the communications. That means in advanced communication in radar and in DRDOs, that means in satellite also. So these are the basic modulation techniques are used. Okay. Now we go for receiver block diagram. So generally here we know the blocks of that receiver one. The received signal is an QASK signal. Please note down parallelly. QASK signal. And here rise, the signal, received signal, rise, the received signal as softening to mth power, then that signal is same, whatever may be the blocks that are present in MRA PSK, same block diagram that can be used. And that can be passes through band pass filter. It allows M of naught, and this can be passes through frequency divider divided by m. Then you will get cos omega naught t and sin omega naught t. Then the signal are given to synchronous demodulator. Again, here another multiplier is there. The received signal is given to another multiplier, and here we can use integrator. Here also another integrator. The outputs of the integrators are given to analog to digital converters. Analog to digital converter. Here also analog to digital converter. So then you will get VK plus 1 here, VK plus 2, VK plus 3. This is general, this is the integrator. So integrates the signal in the distributor. You will get here A of t. Similar way here also 0 to Ts, D of t, A naught of t. Okay. So this is a block diagram. This is a multiplier one. Multiplier is nothing but synchronous demodulators. So S of t, received one is a S of t. Okay. So this is the block diagram. Here you can observe that up to this modulation technique, the receiver block diagram is similar to those PPSK and QPSK, the MRA PSK also. Here we can observe that. In all those modulation techniques, the same phase are different. In first three are the phases are different and amplitudes are constant, same amplitudes for each symbol. But in this case only, amplitudes are different and phase also different from symbol to symbol. Here we can remember. The remaining all are same. But equation, here we can derive the equation for this one is entirely different. From the constellation diagram here, we can derive that equation. Please remember. Okay, the procedure here, once again look into that one. How we can derive that equation. That is very, very important. Okay, so this is the procedure. First, you have to draw the constellation diagram for this one. Then here let us assume the distance between two symbols are 2a, like that. Then we can assign the values. Then here we can, let us assume, here we can indicate that. So 8 QASK is there. What is the constellation diagram for this one? 2 to the power of 3 is then 8. Constellation diagram allows the 8. One symbol, second symbol. Each one consists of only 3 bits. One. This is the another one. This is one. Here, 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 here. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. 8. This is the U1 of T. This is the U2 of T. So let us assume here the distance between this one D is equal to, let us assume 2A antunaram. 2A. Here we can allow this one. Then from this one, let us assume A comma A, 3A comma A antunaram. Then find out ES for each one. From that one, here you can find out A. Then we can substitute this one. Like that here, we can design that 8 QASK system. Are you understand how we can design the any system? QASK systems according to from constellation diagrams. Constellation diagrams మీరు డిజైన్ చేసుకోగలిగితే ఈజీగా మనము డిజైన్ చేసుకోవచ్చు. ఓకే. Hello, my voice is audible to you? ఏమా మధ్యలో మాత్రం మిస్ అయినట్టుంది. స్క్రీన్ విజిబుల్ అయిందా నాది? ఏమా ప్లీజ్ రెస్పాండ్. హలో, రిసీవర్ బ్లాక్ డయాగ్రామ్ నోట్ చేసుకున్నారా? ప్లీజ్ రెస్పాండ్. Okay. Now, shall we stop here only? Next class I will start frequency shift keying. Okay? Please respond.
Okay, ma'am.
Okay na?
ఓకే మ్యామ్.
రిసీవర్ బ్లాక్ డయాగ్రామ్ నోట్ చేసుకున్నారా?
Yes, ma'am.
ఎలా డిజైన్ చేయాలో అర్థమైందా మీకు? ఏమా? సరే, ఓకే. ప్రాక్టీస్ చేయండి. ఏమైనా డౌట్స్ ఉంటే నాకు చెప్పండి. ఏమా? ఓకే. Shall we stop here? We can leave the meeting. Thank you. Thank you.
Thank you, ma'am.
Thank you.